All right, here we go. Practice midterm exam, calculus 1. Question number 1, it says evaluate the function at the given values. These are going to be radian values, so you need to be in radian mode. And then if you have my calculator, you can simply use the fraction button and do sine of negative 0.2 divided by negative 0.2. So we would say 0.9933. So next, instead of negative 0.2, we need negative 0.1, top and bottom. Survey says. And rinse and repeat one more time. Now negative 0.01. And at this point, I'm not sure 4 decimal places is going to be enough. So 0.99998. And did y'all notice that these x values, as we're going to the right, are getting closer and closer to 0? What is the function value approaching? It looks like it's approaching 1. But in order for that to be the limit as x approaches 0, doesn't it have to approach the same thing from the other side? And so now we're going to do these other values and see if we approach the same thing. And on your calculator, that's freaking easy. To do the next one, you just delete the negatives and we get the same value. 0.99998, 0.9983, 9933. You can do the button pushes if you want, but you're going to get symmetric values. And now can we answer part B? What do you think the limit is approaching? Y'all see that it does say as x approaches 0, and the x values are approaching 0 from both sides. Our function is approaching a value of 1. All right, are we ready to do problem number 2? Part A, we want the limit of this function as x approaches negative 3 from the left. Here's negative 3 as we approach from the left. How high is the y? It looks like we're approaching a height of negative 2. Do y'all see this is a one-sided limit? Now the next one, where we're just approaching negative 3, that means from the left and the right, the fingers have to come together. Do they? No. And so what would that limit be? That one does not exist because we don't approach the same y from the left and the right. Part C, the limit of the function as x approaches 4. Do you see that the graph from either side approaches the same height? And what is that? 2. Even though the function value isn't that value, remember the limit doesn't care what it is. Now the next part kind of does. Part 2, it says from the previous graph, give the x values for which the function is discontinuous. Okay, so let's look at that graph one more time. What would be the first x going from left to right where the graph is discontinuous? It does also say that you have to specify the reason from the definition of continuity. Now, do y'all remember there were 3 criteria for a function to be continuous? Remember, the limit had to exist, the function value has to exist, and then the limit value has to be the function value. So which one of those 3 criteria does this fail at? The limit as x approaches negative 3 of f of x does not exist. That's why it's not continuous. That's the first place that it fails at. Is there another x value where the graph is not continuous? 0. And going back to the function, can y'all tell me why it's not continuous? Now you can say it's not defined or you can say doesn't exist. Either one is fine. Is there another x where we have a discontinuity? 2. And again, looking at the graph, what is the reason for that discontinuity? The limit as x approaches 2 of the function does not exist because we don't approach the same y value from the left and the right. And is there any other points of discontinuity? 4. And the reason? And remember, that was the 3rd criteria for the continuity. The 3rd criteria was if the limit exists and the function value exists, that they have to be the same. Part 3, find the limits by using the limit laws. And so thanks to technology, I can actually zoom in on each one of these so you can see it better. Are we able to calculate this particular limit by direct substitution? Do you see that would create an undefined situation? But what we can do here is we can consider what happens as we approach 3 from the left, and then what happens as we approach 3 from the right, and see if we can figure it out pretty easily that way. If I approach 3 from the left, that would be like 2.9, 2.99, 2.999. If I do that subtraction, will the denominator be negative or positive? Negative, correct? But it's getting smaller and smaller and smaller, which means the overall fraction will get bigger and bigger and bigger. If the denominator gets smaller, the fraction overall gets bigger, but it's going to be negative, correct? And so that would approach negative infinity, because the fraction will get infinitely large if the denominator gets infinitely small. And then if you come in from the right, that would be 3.1, 3.01, 3.001. Would this subtraction be negative or positive? Positive. But again, the denominator is getting smaller, so the overall fraction gets bigger, but it's going to go to positive infinity this time. And can y'all see those are not going to approach the same value? So the limit is? Next. So what is x approaching this time? Do y'all understand that means on the number line we're going to the left as far as we can go? Negative, really big numbers. So if x gets infinitely large, is adding 1 to it going to make any difference? No. So this will eventually go to, I mean, if you think about it, the exponent's going to get infinitely large, but it's going to be negative. And then what do we know about negative exponents? Yeah, they're not happy. They want to be positive. So what I can do is I can write it like this. So if the exponent of the e gets infinitely large, what's going to happen when I evaluate e to that power, right? So e to a really big number is just going to be a really big number. But if the denominator gets big, the overall fraction gets small, and eventually will go to 0. So here we can see the numerator is going to go to 0, and then 0 over 4 is 0, so that's going to approach 0. Next, is this a limit that we can do by direct substitution? Even though we're approaching from the left, that still means that eventually we could get to 1. And as long as plugging in 1 doesn't give us an undefined situation, we can figure this out by direct substitution. Let's see if that works. So can we calculate the natural log of 1? And if so, what is that value? But then do y'all remember that an inverse trig function actually equals a theta? So now can I move the cosine back to the other side and go to my unit circle and find an x coordinate that has a value of 0? And where would that be at? So that means the limit would be pi over 2. Next, can we evaluate and find the limit of this function? No, you can't. It's going to give me a 0 in the denominator. We can't evaluate. Hey, but maybe we can factor and eliminate that problem. And I tell you what, I'll factor the bottom if you'll factor the top. Okay, I got my part done. Okay, from the front row, I heard 5x plus 2. And what would the other factor need to be? Now that we have it factored, can we reduce the fraction? And did you see that that does eliminate our divide by 0 problem? So now doing direct substitution, that's going to be 5 times 1 plus 2, 1 plus 1, and then that limit should be 7/2. Next problem. We have a piecewise function, and did y'all know that for this to be continuous at the transition point, these two functions have to have the same y value? In other words, when I evaluate the top piece at pi over 2, it's got to give the same value as if I evaluate the bottom piece at pi over 2. So now can you see how we need to set this up so that we can find the value of c that will make this continuous? Do y'all see what we did? We evaluated each piece of the function at the transition point, and they've got to be equal. And so now again, you're going to have to go to your unit circle or simply know what is the sine of pi over 2. And then for the cosine, the 2's cancel. What is the x coordinate at pi? And now can I solve that for c? Okay, I'm going to move the 4c. And that's going to make the 4c positive, but that's going to make the 1 negative. And then if I combine like terms and divide by 2, everybody understand you're going to have to show the work to get credit for that, right?
Yes.
You can't just write c equals -1 without any supporting scratch work. Next problem, use the intermediate value theorem to determine if the following equation has a root on the interval from 0 to pi. Now the problem is this is not a function, it's an equation. Can we set this up as a function? Answer is yes. If we simply move the cosine of x over, that would set it to 0, but then we can say that's f of x. So we can write this as a function, and then what we need to do is evaluate the function at 0. Okay, so again, does anybody know the value of cosine of 0? That 1? 0 minus 1 minus 1? Is that minus 2? Yep. And then f of pi. Pi minus 1 minus cosine of pi. So then that's going to be pi minus 1 minus a -1. But minus a negative is going to make that a +1. And can y'all see the -1 and the +1 are effectively going to cancel? Yeah. Did my function values have opposite signs? And then that implies, yes, it does. Since f of 0 and f of pi. Find the vertical and the horizontal asymptotes, if any. So to find the vertical asymptote, we need to set the denominator equal to 0 and solve. So we need to move the -5 to the other side so that we can isolate the exponential piece. And then at this point, we can convert to logarithm. And we've got a vertical asymptote. To find the horizontal asymptotes, you have to consider the limit as x approaches -infinity of the function, and then you also have to consider the limit as x approaches +infinity of the function. Next, limit as x approaches -infinity. Again, do y'all see that that would be e to a really big negative number? But making the exponent positive would make it 1 over e to the really big positive number, which would mean that this would effectively go to 0. Again, if you plug in a really big negative number here, e to the really big negative number is effectively going to go to 0. But then that would be 2 over 0 minus 5, which is y equals -2/5. And then as e goes to +infinity, wouldn't that make e to the x infinitely large? In fact, it's going to get so big that eventually subtracting 5 from it is going to be insignificant, right? Okay. So here the denominator is going to go to infinity, but the numerator is going to stay the same. So what is that overall fraction going to approach? 0. And that's going to be my other horizontal asymptote. Next, find the equation of the tangent line. Notice that they did give me a point. What is the only other thing I need to write the equation of a line? I got to have the slope, right? And so to get the slope of the tangent, we need to find the derivative. So we're going to have to find y prime. Luckily, this equation is just a simple polynomial. And you can use the power rule repeatedly to crank out the derivative. That would be 7 minus 2x. And then to get the slope of the tangent, we're going to evaluate the derivative at what x? At the x coordinate of the point that we're at. And that is 3. And then we can go to y minus y1 equals mx minus x1. And we can come up with our equation of the tangent. Y minus 10 equals 3x minus 2, 3x minus 6. Bringing the 10 over would be plus, what is negative 6 plus 10? And we're done. Next, given the function f of x equals the square root of x, notice it does say use the definition of derivative to find f prime of 2. So the definition of derivative in this case would be the limit as x approaches a, f of x minus f of a over x minus a. That is the definition of derivative to find a function value here. What is my a? That's the number I'm going to, okay? So here, every a is going to get replaced with 2, and then x and f of x just stay, well, what they are. So this is going to be the limit as x approaches 2 of the square root of x minus the square root of 2 all over x minus 2. Now, can I evaluate this limit by direct substitution? Because it's going to make a 0 in the denominator. So what we're going to have to do is we're going to have to algebraically manipulate this to avoid that situation. And what we're going to do is we're going to rationalize the numerator. We're going to rationalize the numerator. What am I going to need to multiply top and bottom by? Square root of x plus square root of 2. Square root of x times square root of x. That would be the square root of x squared. But the square and the square root cancel, right? Leaves me an x. And then on the outside, we're going to have positive square root of 2x. On the inside, negative square root of 2x. And what's going to happen to those two terms? Yeah, they will cancel. Last but not least, what is a negative times a positive? Square root of 2 times square root of 2. And then in the denominator, you know what? In the denominator, I'm not going to multiply that out. Okay, in the numerator, square roots cancel. What does that leave me with? And could I write it like this? 1 times x minus 2. Now, did y'all see the reason I might want to write it as 1 times x minus 2? So that it really looks like the factor that's in the denominator. And so now can I reduce the fraction? Now can I do direct substitution and evaluate the limit? Because now when I plug it in, will it make the denominator 0? No. And so we can evaluate the limit now by doing direct substitution. That's going to be 1 over square root of 2 plus square root of 2. But simplifying, that would be 1 over 2 square root of 2. Now, what does this one say? Sketch the graph of the derivative. Okay, so the first thing I want you to do, identify everywhere that our tangent line would be horizontal. Where would we have a horizontal tangent line? That means at those points, you're going to have x-intercepts. Because the slope of the tangent is the y value of the derivative. So everywhere there's a horizontal tangent, you're going to have an x-intercept for your derivative graph. And then somewhere in here in the middle, does it look like the slope of this line would be about 1? Okay, so what I'm going to do somewhere in the middle is I'm going to come up to 1 and put a dot, because the slope of the tangent is the y value of the derivative. Somewhere along there. Maybe it's a little bit farther over. Something like that. Now, what about over here? -1. And so that means that I'm going to be somewhere down here. Do y'all see this tangent line here is going to be about -1? Mm-hmm. Which means that the y value of the derivative should be around -1. And I think that's enough points. Now we can play connect the dots. Something like that. Next. Find the equation of the normal line. Now, do y'all know to get the normal line, I actually have to find the slope of the tangent and then make it perpendicular. But to get the slope of the tangent, what do I have to find? Well, let's start with that. Okay, so what is the slope of the tangent? It's going to be the derivative evaluated at 1, which is -4. Y'all see that? Now, I need the slope of the normal line, which will be perpendicular to the slope of the tangent. And do y'all remember how to get perpendicular slope? Perpendicular line, flip and change the sign. Now do I have a point and the slope? And I can use point slope form. Y minus y1 equals m x minus x1. Plug it into my point slope form. Please make sure you use the normal line slope and not the tangent line slope. That's going to be y plus 5. I'm going to go ahead and distribute 1/4 x minus 1/4, moving the 5 over, just so we can have it in slope-intercept form. Should give me, I think, -21/4. And then part B, find the point at which the normal line intersects the graph a second time. So I want to set the function equation equal to the normal line equation, and then solve for x. So multiply the left-hand side by 4, multiply the right-hand side by 4. So let's move the x and the 21 over. And does that trinomial have any common factor that I can factor out? I think it's probably going to factor, and I'd like to show you a little secret. I mean, we know that this is one of the places that it intersects, right? When x is 1. And so what would that be as a factor? It would be x minus 1 as a factor. Because if you set that equal to 0 and solve, you get 1. Do y'all see how I can use that knowledge to get one of my factors? Yeah. And now it should be pretty easy to come up with the other factor. It's going to have a 4x. It's going to have a 21. And the sign is going to have to be negative, so that a negative times a negative makes up. So x minus 1, we already have that point, right? We need to focus on the other one. 4x minus 21 equal to 0. Let's bring that up here. 4x minus 21 equal to 0. So 4x is 21. So x is, and is that the answer? So I got the x, I need the y. So where can I plug this x into to get the y?
Normal line equation?
The normal line equation or the function. You can plug it in either one. Right, so I can plug this into the normal line equation, and that's going to give me what y is, which is going to be 21/16 minus 21/4. Do you have a scientific calculator that you can simply do that on? -63/16. And now does everybody understand that I do need to finish this problem by writing the answer as an ordered pair? Also, does everybody see that it says give the exact values? Number 12, find the indicated derivatives. Notice that they do want us to find f prime of 3. So we're going to start by finding f prime of x and then evaluate f prime of x. What is the derivative of x to the third? And the derivative of e to the x? And the derivative of a constant. And so that is the derivative. And now we can evaluate at 3. 3 times 3 squared minus e to the 3 would be 27 minus e cubed. Notice that this one just wants f prime of x. And so we just need to take the derivative, but it's a quotient. And so we're going to have to use the quotient rule, which says the derivative of the top times the bottom minus the top times the derivative of the bottom. Does anybody know the derivative of secant of x? Please don't forget the x's have to be on both trig functions. So the derivative of secant x is secant x tangent x. and then all over the denominator squared. And then if it's at all possible, you need to simplify that. So in the numerator, do you see there's two terms? Do they both have a secant x?
They do.
And so what I can do is I can eliminate a secant x. I'm going to show that by factoring it out. And that will leave me 2x minus x squared tangent x all over secant squared x. And so my final answer here could be 2x minus x squared tangent x all over secant x, or an alternate correct answer could be 2x cosine x minus x squared sine x. How did I get that?
Yeah.
I'm so glad you asked. Can tangent be written as sine over cosine?
Yes.
Can secant be written as 1 over cosine?
Yes.
Can I multiply a fraction top and bottom by the same thing? I choose cosine of x. So here I would distribute. That would give me 2x cosine x. Here the cosine x's would cancel, leaving minus x squared sine x. And in the denominator, the cosines would cancel, leaving me just 1. And anything over 1 is itself. That's how you get that. Okay, next. And what do they want me to find? Oh, y'all see double prime. So we're going to have to find the first derivative first and then do the derivative again. But did you notice that this function is made up of two functions?
Yes.
And so it's the product rule. For the first derivative, what is the derivative of the first piece? Derivative of 3x is 3. Derivative of the first times the second, plus the first times the derivative of the second. And the derivative of sine is cosine. So there's our first derivative. And then we can take the derivative again. Now, notice my first term of the first derivative doesn't require the product rule because there's no x here now. So the derivative of sine, cosine, and he just keeps his coefficient. But for the other term, we're going to have to use the product rule again. So we're going to say plus the derivative of the first times the second plus the first times the derivative of the second. And what is the derivative of cosine? Negative sine. And then we need to combine like terms. I've got 3 cosine x plus 3 cosine x. That is 6 cosine x minus 3x sine x is correct. Next, find the slope of the tangent. Does that mean I need to take the derivative? Did you notice that my function is a rational function? And that means we're going to have to use the quotient rule. Here we go. Using the quotient rule. The derivative of the top. The derivative of the constant goes to 0. And does anybody know the derivative of tangent? Is it secant squared? But it's going to be negative, okay? All right, so what do we say? It's the derivative of the top times the bottom minus the top times the derivative of the bottom. And does anybody happen to know the derivative of secant of x? All over the bottom squared. Let's see here. Y prime. Does anybody know what secant squared times secant is? Secant, could I write it like this? Isn't secant 1 over cosine? Minus 4. Secant is 1 over cosine. Tangent is sine over cosine. And then I'm going to come back and put squareds on those. Because did you see I've got tangent times tangent. Sine over cosine times sine over cosine. Sine squared over cosine squared. All over 1 over Is this the only way you can do this problem? No. And I may be doing it the more complicated way, but at least what I've done is not wrong. Can I multiply through by cosine squared x, which is going to give me 1 over cosine of x minus 4 sine of x plus sine x tangent x. Okay, so in the denominator, those cancel, right?
Yes.
And it gives me all of this stuff over 1, which is just all the numerator. Now let's replace every x with?
Pi over 4.
All right, so I don't know if y'all noticed, do you see what I did here is I went through and replaced every x with pi over 4. So that's going to be negative 2 over square root of 2 minus 4 square root of 2 over 2 plus square root of 2 over 2. And then let's see if we can simplify that. Okay, rationalizing. That's just going to be negative square root of 2 minus 3 square root of 2 over 2. Actually, if I convert that and leave it, 2 square root of 2 over 2. And now I have a common denominator again, and I should have negative 5 of those. Questions about that? Next problem, we're going to talk about the chain rule. And I know I did several examples where we did a U substitution. So here is where we're going to check and see if you caught any of that. First things first, what would I let U equal to?
X squared plus 4.
It even gives you the hint that that needs to be the inside stuff. And then what would I let Y be?
Squared.
Do y'all see that? It says that Y would be a function in terms of U. And so you come back over here to your function and you say, okay, if I let U be that stuff, then this would be the square root of just U. That's what Y is. And then it wants me to find what? Yeah, but dy dx. Now, this is where the formula comes in. dy dx is first going to be dy du multiplied by du dx. This is a formula covered in the book. Probably covered in the notes when we covered the chain rule. So if I want to find dy dx, I first need to find, do y'all see what this says? The derivative of the y with respect to u. So we need to find the derivative of this one first, okay? Which would be y prime. And I hate mixing the notations. So this would be dy du. Can I change that square root to a 1/2 power?
Yes.
It sure would make it easier to just do the power rule. Did y'all see what I changed? I changed the square root to just a 1/2.
Yeah.
And then we're going to do the power rule, which is 1/2 u to the negative 1/2.
1/2 2 u squared, or square root of u.
Or 1 over 2u to the positive 1/2 if I move the u down. Or that. All right, so let's see if you follow me. All of this work here was to get the dy du. And now do you see what I did to go from here over to here? Is I substituted and I replaced u back to what it's supposed to be. I replaced the u with what it's equal to. This is this. And then what do I need?
What you times the u.
Now I got to take the derivative of this guy. Well, that part is easy. And that means that this needs to scoot down. Like so. But if that 2x is out to the side, can I just stick it in the top?
Yes. Yes.
Oh, I could. Did y'all see the 2's cancel as well? Nice. Maybe I need to show that in a separate step.
If we're confident with the practice test, would that be enough to go into the test?
It has to be. Actually, if you were confident with the practice test and then all the homework and quizzes you've taken in this class, then you would feel really confident. Yeah. Oh, I'm sorry. Yeah. What do I have? 4 more to go?
Yes.
And we get out at 12:50?
12:20.
Okay. Well, that gives me 40 minutes still, right? That's 10 minutes per question remaining. I'm pretty sure I can do it. Now can I move on? Okay. Next, use implicit differentiation to find, look what it wants. Equation of the tangent. So do I need to find the slope first? Did they give me a point?
Yes.
There. Okay. And notice it said to use implicit differentiation. That's because not only do we have a y here, but we have a y over here also. Ready? Okay. Using implicit differentiation, the derivative of y is 1. But since I took the derivative of y, I have to attach a y prime. On the other side, this is sine of theta, where my angle is the product of 2 different variables. Now, did y'all remember to take the derivative of a trig function? If this angle is not just x, then you have to do the chain rule. So you'll have to take the derivative of sine. The stuff inside stays the same. And then you multiply by the derivative of the stuff inside. All right, here we go. So the derivative of sine, the stuff inside stays the same. And then you have to multiply by the derivative of the stuff inside, which is going to require the product rule. So the derivative of the first times the second. The derivative of the first times the second. What is the derivative of x?
1.
Times y to the 5th? Does he need a y prime?
Yeah.
No. Make me connect. Why does it not need a y prime? Because I didn't take the derivative of something with a y. I took the derivative of the x, okay? And then plus the first times the derivative of the second. What is the derivative of y to the fifth?
5y to the fourth times y right. Have y.
And he needs a y prime. Because I took the derivative of a y. And do you see that finishes the chain rule?
Yeah.
The derivative of the trig function, stuff inside stays the same. And then multiplied by the derivative of the stuff inside. Can y'all see that is a binomial? So will the cosine need to distribute to both of those terms? And the answer is yes. All right, so we're going to have y to the fifth, cosine of x, y to the fifth, plus 5 x, y to the fourth, cosine of x, y to the fifth, times y prime. I'm sorry?
You don't distribute the cosine to the y prime.
What do you mean into the y prime?
You distribute the cosine x, y to the fifth to every other variable except y.
No, to each term.
Yeah.
To this term and to this term. You see what I did is I moved these factors here to the front. I inserted the cosine function right in here. And then the y prime at the back, okay? So the answer is no, you don't multiply the cosine times each one of these, because these are factors, not terms.
Next step, when we subtract stats, and then we move to the other side, right?
The next step is I do have to get my y primes together on the same side so that I can factor out the y prime and then solve for the y prime. So we are next going to have to move all of this junk here, all of this term to this side and factor out a y prime. And I will do that all at one time. Now, did y'all hear me say that when I move this term over, I'm going to factor out the y prime? Do you see this term is simply y prime?
Yeah.
What do I have left if I factor a y prime out of this guy?
1.
1. So I'm going to have a 1 minus 5x y to the fourth cosine of x y to the fifth. Because if I bring this term over, it's going to become minus, and I'm going to factor out his y prime. And then what does that equal?
Y to the fifth, x, y to the fifth.
And then can I divide both sides by all of this stuff in the parentheses? Cancel. I'm sorry, does everybody see now that that fraction represents the slope of the tangent?
Yeah.
That fraction, all of that mess is the derivative. Now can I replace every x and y with the x and the y from the ordered pair?
Yeah.
And simplify that down to the slope. Okay, here we go. Y is 1. X is pi over 2. Woo! Man, oh man, doesn't that look exciting? At least I chose a nice point.
Yeah, at least it wasn't 2
Yeah.
instead of 1.
I mean, do y'all understand why pi over 2 is going to be super nice here?
Because cosine of pi over 2 is 0.
It is.
Oh.
Because cosine of pi over 2 is 0. And so any of these angles that simplify down to pi over 2, when I take the cosine of that, is going to disappear. It's going to become 0. So what is that going to be? That's going to be
1 minus 0.
good grief. That's the hardest I've ever had to work for nothing.
But you always guess zeros.
No.
It's super risky.
No.
0 is super risky. This doesn't happen.
Did you say guess?
Yeah, zero. Yeah, if you don't know how to do it, guess zero.
Okay, and then you didn't show any work, so you get no credit anyway. Now, what do you know about lines that have a slope of 0? And what is the equation of a horizontal?
Y equals
a number.
oh constant.
Y equals a number. What number will the y be?
1.
Well, it'll be the y from the ordered pair. You know why? Because the line has to go through that point.
Yeah.
Good grief. Look at all that work we had to do
Where's 0?
for just y equals 1. Why is y 1?
It's over here. The points.
Desmos it up.
1.
I did check this on Desmos as well. The graphing this thing in Desmos is freaking weird looking. But when you look at this point, it is definitely horizontal. Did you get an answer to your question of why it's 1? Because the coordinate is 1, yes. But why isn't there an x? Because the slope was 0. Okay, do I need to plug into the point slope form? I will. Y minus y1 equals m x minus. Do you see what happens when I plug into the point slope form?
Yeah, just because y
0 times anything is
0.
0. And then I move the minus 1 over. That's another way you can verify that it's y equals 1. Can I move on? Now we're going to differentiate. All that means is find the derivative. And I don't know if you noticed this or not, but this first function is going to require the product rule. We've got a t and a t. We're going to have to do the product rule. Here we go. Wait a second. Not here we go. Let me think for a second. I think the first thing I want to do is rewrite this without the cube root. Does everybody agree what I've done there on the first step is I've just gotten rid of the cube root and written it in exponential form with an exponent?
Yes.
Notice I didn't put a prime because I didn't start the derivative yet. I just changed the form. And now I can put a prime. And we're going to do the product rule. So the derivative of the first means I'm going to have to multiply the exponent times the coefficient.
Yeah.
What is 1/3 times 3?
1.
1. T to the,
I do 2/3.
right? Because I have to subtract 1 from the power.
Yeah.
1/3 minus 1 is a negative 2/3. I'll fix that in a minute. That is the derivative of the first times the second plus the first times the derivative of the second. Does anybody know or remember the derivative for natural log?
1/2.
Isn't it 1 over x?
Yes.
Derivative of natural log of x is 1 over, but what is my x this time?
9/2.
And since it is 9t, I would need to multiply that by the derivative of 9t. It's going to be the chain rule. Since this is not just x, then I would have to do a u substitution and do it just like we did the chain rule in the previous problem. So the derivative of 9t is 9. And then I need to take that to my scratch paper and simplify. What was it again? T to the negative 2/3. Natural log of 9t plus 3t. 1 over. There just wasn't enough room on the test for me to show all the work I need to simplify. So we're bringing this over to the scratch work, okay? Now, we're going to have natural log of 9t over the cube root of t squared. And let's make sure everybody understands how we got that. If this is negative, I need to move it to the bottom. But then isn't the denominator the root?
Yes.
And the numerator the exponent. So I put it back into radical form. And then on the other one, do y'all see that these 9s would cancel?
Yes.
And so that would leave me 3 cube root of t over t. And then since these are both t's, can I simplify that? Maybe I need to leave that as t to the 1/3 for a second. Okay, if I leave it as t to the 1/3, do you see that I have t's top and bottom? And then can I reduce? Which has more t's, top or bottom? Now the top only has 1/3 of a t. He's got a whole t.
Yes.
So how do I find out what his exponent is going to be? I subtract.
Oh, I see.
Do you see if I reduce those variables, I'm going to have to subtract the smaller exponent from the bigger one. And then where the bigger one was is where they're going to end up at. So what does that leave me with? Is that natural log of 9t over the cube root of t squared plus 3 over is that also going to be the cube root of t squared?
Yes. Yes.
Because 1 minus 1/3 is 2/3, which is positive. And then I can convert it back. And now do I have a common denominator? And then can y'all see what I wrote here back on my test? Is that the correct answer? Simplified completely. Yeah. Can I move on yet to the next one? I'm sorry. Would you like to look at this again? Okay. And I'm going to increase the font size a little bit so that you'll understand it better. The bigger the font size, the better you understand it. At least that's my hope. Now, are we ready to move to the next one? Okay, next problem. We need to find y prime. And that is going to be 7 times. I'm going to need you to pull up your formulas for the derivative of inverse sine. In your formulas, what is the derivative of inverse sine of x? 1 over the square root of Can anybody verify? I just would like verification. In your notes, is the derivative of inverse sine of x 1 over the square root of 1 minus x squared?
The derivative of x.
Say it again.
Derivative of x on top.
So the derivative of inverse sine has an x on top already? Is it x over?
X prime. X prime.
X prime?
You will
Yeah.
multiply.
Oh, okay. That's what I'm getting. I'm not there yet, okay? What I'm trying to find out is if this x squared was just x.
Yes.
The derivative of inverse sine is 1 over the square root of 1 minus x squared.
Yes.
Now, but this wasn't just x, it was x squared, which means I'm going to have to use the chain rule. So since this is my x, then that's going to have to be squared in the formula. And then I'm going to have to multiply by the derivative of the stuff inside, which is 2x. Y'all agree with that? And then I need to simplify. Let's make these fractions. Okay, so in the numerator, 7 times 1 times 2x. In the numerator, 14x. In the denominator, square root of. There it is. There's derivative. There's the derivative of 7 inverse sine of x squared using our formulas for the inverse trig functions. Question.
Is the inverse of sine 1 over sine?
The inverse of sine, 1 over sine. Now the reciprocal of sine is 1 over sine.
Okay.
Inverse doesn't mean the same as reciprocal.
And reciprocal sine is secant, right?
Cosecant.
Cosecant.
Yes. Inverse is not reciprocal. Okay? The main thing you need to know is you need to know those formulas for your derivative of inverse sine, derivative of inverse cosine. Was there a derivative of inverse tangent? You need to know those derivatives, okay? They will not be on the formula sheet. You'll need to know those. Can I move on? Can I move on? Okay. The height of a projectile shot vertically upward from a point 5.5 meters above the ground with an initial velocity of 25.48 meters per second after 2 seconds is represented by, and then here's the equation. Can you tell that it's quadratic?
Yeah.
So I'm going to want you to calculate the time at which it reaches its maximum height. Would it also be correct to say I need to know when it reaches its maximum height?
Yes. Yes.
When is time, right? But did you see the time is where the x's are? And since it's quadratic, it makes a,
Parabola.
where do we find the maximum value of a parabola? And y'all know the vertex is an x and a y, right? But here the x is the time, which is what I'm asking for. So all you have to do to solve this with college algebra is find the x coordinate of the vertex. And that formula is minus b over 2a. Back in your college algebra to find the x-coordinate of the vertex, which is h. Yes, sir.
Could you also find the derivative of it, because that would mean velocity, and at the maximum height, the velocity is 0.
That's this. So you're going to have to find it using college algebra and calculus. What you're telling me is how we're going to do it the second time. So when you said, would it be okay if we do it that way? The answer is no, you have to do it that way. Now, what is my value of b?
25.
And a? And calculator. 4.6, 2.6. Seconds. That is the college algebra technique. Now we're going to do the calculus technique, which says we need to find h prime of t and set it equal to what?
0.
Right? Because when it reaches its maximum height, the slope of the tangent will be 0. It'll be a horizontal tangent line. All right, help me out here. Taking the derivative of a constant? 0. The derivative of just a t? Does he just lose his t?
Yeah.
And then the derivative of, well, here we're going to have to use the power rule. 9.8 t, set it equal to 0, and solve for t. So we'll have 9.8 t equals 25.48 divided by 9.8. And it should be no surprise that we get the same answer. You better get the same answer, regardless of how you do it. And now for part B, how would we figure out what its maximum height is? Not the derivative? The original?
Yeah.
Okay. So let's calculate h of 2.6. 5.5 plus 25.48 times 2.6 minus 4.9 times 2.6 squared. I have seen students do all of this work correctly and simply forget to put the squared here. Right? That would be a partial credit issue. Like you're demonstrating that you know what to do, you're just also demonstrating that you're not perfect. And does anybody have an outcome yet? 624 meters. 38.624 meters. Question, can anybody verify that? Verification.
Yeah.
Do y'all see we're to the last problem? And I've got to make it last 15 minutes. Okay. I would like you to notice that I did save the best for last. When it says use the precise definition of a limit, this is a delta epsilon proof. Yes, we are going to use a delta epsilon proof to prove this limit, okay? Now, what does it say here? You may write whatever you need to prepare for the proof. Your work after the word proof is what will be graded. All right, here we go. Are you ready? So the delta epsilon proof said something like if the absolute value of x minus a is less than delta, that it implies that the absolute value of the function minus the limit is less than epsilon. Do y'all remember that part of the definition? Precise definition of the limit, okay? So what we're going to do is we're going to start with what we need to happen and determine what we need to make it happen, okay? What we need to happen, I'm going to call this my scratch work. We need for the function, by the way, what is the f of x in this case? It is 2x plus 3 minus, what is the limit? Minus 5. We need that to be less than epsilon. We really need that to be less than epsilon, okay? And then we're going to simplify that. So what is 3 minus 5? Can I then factor out a 2? Can I then take the 2 in front of the absolute value? Can I then divide both sides by 2? Do y'all see what I've done so far? You know, listen, I'm going to scroll up. Do y'all see now that we have arrived at this piece where A is that what A was?
Mm-hmm.
Yes.
Oh yeah, because A is what I'm approaching. So now, since we've arrived at this piece, we now know what to let delta be. Right, okay, so now for the proof. Okay. If if epsilon is greater than 0, epsilon has to be a positive value. We're going to let delta be what? Okay. Then x minus 1 less than delta. Y'all see, it says if this happens, and that's what we're starting with. Yes. And we said let delta be, so I do a substitution. I replace delta with what I want to let it be. And then at this point, could I multiply both sides by 2? And then could I bring the 2 inside the absolute value? And then could I distribute the 2?
Incredibly complicated.
But then can I express negative 2 as 3 minus 5? And do you see now? Now I have shown if I let delta be epsilon over 2, then if this is correct, then this is correct. And that's the way you do the proof.